Hello class. So we like to look at the part 2 of our review questions here. So let's get started. You have the twice differentiable function. That means when you take the derivative twice, it'll still be giving you the values without not being defined. Now, given that here we have graph that goes this way, you will realize that since the concavity is negative, so we get to realize that second derivative has to be equal to less than 0. While f of 1 is in fact equal to 0 here, and not f of 1, not f prime, and then f prime, but since it's increasing function, has to be greater than 0. That means f prime is the biggest, where f double prime is the smallest, which is choice D becomes our answer, therefore. Alright, we're looking at the equation of line tangent to this graph at point 0, 1. Then we have to find the slope. What is the slope here? Y prime. Derivative of x becomes 1. Derivative of cosine becomes negative sine of x. By plugging in 0, we get to realize when x equals 0, this is still stay as 1, minus sine of 0 is equal to 0, so 1. Slope is equal to 1, which we are talking about these three values. When you plug in 0, you have to get 1. That means choice B becomes our answer. How about here? We have double derivative given, which shows the concavity. Point of inflection or inflection point here, you will realize that whenever you have a single root, you will realize sign will change about that value. Meaning in this case 0, and then in this case negative 1. But in this case, when you have 2, when x equals 2, because of the double root, the values about when x equals 2 wouldn't change. So therefore, inflection point talks about the points where concavity changes. That means we are looking at 0 and negative 1 only, which is choice C. Now this one has to be equal to 0. Now notice that the little visual might help you a lot because we have a function, simple parabola. Now starting from negative 3, we are measuring the area from negative 3. How far do we have to go so that we can get 0? In fact, when you start and end at the same point, negative 3 should be fine. When you go to 0, then we'll end up getting this much area. When you go for 3, then we're going to get the double the area. Therefore, only possible value for k where this will be equal to 0 is when k is equal to negative 3. Alright, so we have some sort of differential equation. Then what is y could be? Then in this case, what we can get is this. Put it over 1, we can separate, so we have dy over y, which will be equal to k dk. Then when you integrate both sides, then we end up getting what is 1 over y? That's right, it becomes ln of y with the absolute value, and then here it becomes kt plus c. I have no idea what c would have been. Now to get rid of ln, we're going to raise each side by, that's right, some sort of exponential, let's say e, then we end up getting y is equal to e to the kt plus c. Notice where I put c here. C is still the exponent. That means this is equal to e to the kt times e to the c power. Notice that plus c we have no idea, but when two numbers are adding an exponent, that means those two numbers are actually multiplying. But since I don't know what c is, this will e to the c becomes another constant. Let's say if I call this one as a c of 1, then this can be c of 2 as an example. E to the kt. So that is what we are looking for. So anything that has this concept, it seems to be choice B. B becomes our answer. All right, number 22. So we have this function given where f is increasing. The fact that it is increasing, then we have to look at where f prime is positive. Let's try to find f prime. Here we have 4x cubed and then plus 2x, and that becomes 0. To factor this one, we have 2x and we have x squared plus 1. Now notice that this will never be equal to 0. Or I forgot 2 here, sorry. This will never be equal to 0. Well, this could be equal to 0, so therefore only possibility is when x equals 0, where f prime will be equal to 0. Now how about the values above that, such as 1? And this is positive, well this is still positive, okay. How about here? When x is less than 0, this becomes a negative, well this one is still positive. So negative times positive becomes negative. The fact that f is increasing, that means we are looking at this portion where f prime is positive. Since this is relatively just simple polynomial function, it's going to be when x is greater than 0, the function is increasing, which tells us by choice C. Alright, so here we have, this is the function that's given. Derivative of f. Whenever you're looking for derivative, one of the biggest point is the horizontal location here. Where the function is horizontal, at that point, the derivative has to be equal to 0. So where do we have that? Maybe this one. Not really. Not really. Maybe this one. And maybe this one. We have 3 possibilities here. But the left side of that, the derivative is positive, as you can see, it's increasing. While after that, it has to be negative. Positive and then negative. This one is positive and then negative. This one doesn't work. This one is positive and then negative. So in fact, choice A and then choice E is very strong candidate. Here, now when you look into this one looks like some sort of the trigonometric function. So therefore, when you try to find the derivative of that, it will still be another trigonometric function, per se sine versus cosine. Or another way of looking at it is this. You see the slope here is equal to 0, but slope is what? Coming down, and then as you go towards A, slope one more time becomes 0, which is described here, but not here. Therefore, choice A becomes our best answer. Number 24. So maximum acceleration. Now we have to look at the acceleration, but from there we are looking for the maximum value of it. Then what is the acceleration? Acceleration can be given 3t squared minus 6t plus 12. Now, then in this case, one thing which we get to realize, the derivative is the quadratic, as you can see. How can you find the maximum of this? You not only have to look at where this value is equal to 0, but also 2 endpoints. So when do you have derivative of this, meaning jerk, or I'm just going to call it as a prime, is equal to 0, that's when you have 6t minus 6. In other words, when t is equal to 1. So what we have to do is set out a simple chart, t and then a, 0, 1, and 3. When you plug in 0, what do you realize? This becomes 12. When you plug in 1, we get to realize that 3 minus 6 plus 12 becomes, I believe it becomes 9. When you plug in 3, it seems to be, this one is 27 minus 18. So 27 minus 18 plus 12. Definitely a value that's greater than. In fact, yes, this becomes 21. So in fact, when t equals 3, that's when we have maximum acceleration, whose velocity is given by. So a maximum acceleration becomes when the 21 becomes our answer, choice D. Alright, number 25. What is the area between this graph and this graph from 0 to 2? If you're to sketch it, then I believe it will be easier for us to see it. And then, that's basically what we have, and then y equals negative x goes down this way. So 0 through 2, approximately we are looking at this area. How do you find that area? Area basically goes from 0 through 2. Upper function was x squared minus the lower function, which is negative x dx. Then this simplifies into x squared plus x dx from 0 through 2. Then what do we end up getting? Yes, it becomes x cubed over 3 plus x squared over 2 for 0 through 2. When you plug in 2, we end up getting, becomes 8 over 3 plus this portion becomes 2 minus 0. Then here we have 14 over 3 becomes our final answer, which is choice D. Number 26. The function f is continuous on this closed interval and then has the value given by in the table above. If f of x is equal to 1/2. I have no idea what x is, but y value is supposed to be equal to 1/2 somewhere along this line. Must have at least 2 solutions if k is equal to. Now, let us try to look through this one together. So we know the two values, 0, 0, comma 1. 0, comma 1 is, let us say, around here. Oops, not that value. 0, comma 1 is right over here. 1, 2, and then becomes 2, comma 2. So 2, comma 2 is over here. Now, normally, and the f of x equals 1/2 must have at least 2 solutions. What does that mean? That means if I were to draw a line 1/2 over here, you will realize there are 2 places where the function cuts across. How can we have that? That's only if possible where this value of k has to be below this 1/2. If it to be 1/2, then it can possibly be only one particular point, but if it's below that, for example 0, I'm just randomly drawing a function that goes like this way. Then as you can see, you will see 2 places where value of x can be found. So therefore our answer would be choice A. Number 27. What is the average value of that? Basically the expression is average value goes from 0 to the 2 of x squared square root of x cubed plus 1 dx all over 2 minus 0. How are we going to integrate this one? Yes, by the U-substitution. If you let u is equal to x cubed plus 1, you will realize that du is equal to 3x squared dx. Since we have x squared dx here, what we have to do is we have to divide by 3. Then this will give us x squared dx becomes du over 3. So using that, we will be able to realize that this expression, I'm not going to write down the intervals, but we're going to write it as square root of u du over 3. That's basically what we can do. All over 2. I intentionally skipped the interval because 0 through 2 is not necessarily the same interval when we transfer over to the domain of u. Now, then in this case, how can we integrate this one? Since u is equal to u to the 1/2 power, when you integrate this one, I'm going to just bring 3 over 2, 3 and then 2 here to the front, which makes 1 over 6, by the way, u to the 1/2 power du. And this becomes u to the 3 over 2 power, and then multiplied by reciprocal, which is 2/3. Since u is equal to, we know the value of u, 1 over 6 times 2/3 square root of x cubed plus 1 from 0 through 2. Here we end up getting 1/9. If you plug in 2, we end up getting square root of 9. If you plug in 0, we get square root of 1. Simply becomes 2. So 2 over 9 becomes our final answer. 2 over 9. Oops, I think we might have made a mistake. Here, that's okay. Oh, we made a silly mistake here. I forgot to carry over 3 as an exponent over here. So we should have raised this one by 3 power. Then this becomes to the 3rd power. And 3rd power right over there. Then instead of 2/9, it becomes, here we have 3. 3 to the 3rd power becomes 27. So 1/9. 27 minus, here still becomes 1. So we end up getting 26 over 9 becomes our final answer, which is choice A. Alright, thank you, and I'll see you guys later. Bye-bye.